Okay, so now that we've kind of defined what a function is, we're going to talk about function notation. So we did see a little bit of function notation before, but we're going to really explain what it means. So we had brought up before that basically this fx is essentially your y. But like I said, let's go a little more in depth on that. So if you're given that x as an element of the domain, this means it's an input, and y is an element of the range, essentially meaning it's an output, then we can say y equals f of x. So we say that is like f of x. Y equals f of x represents a functional relationship between the domain and range. So what we're saying is that this is representing a function. And kind of way we talk about this is we say y is a function of x. Another way I like to think about it is output is a function of input. So what we're saying here is that every y that comes out, it's going to be unique y, and it's always based on the x that we put in there. Another way we say this is f of x is a function of x, as opposed to saying the y. So y equals fx is a name of the function, and with x representing our input or independent variable, and with y representing our output or dependent variable. Sorry, dependent variable. So I believe we'd also had seen this before as well. And that is still, we're talking about a function. It's just that time we just call it g of x. So we can have other names for functions, or we can have other variables. It's not always x and y. X and y just tends to be the go-to. F tends to be your go-to for a function name. So if we happen to be working with multiple functions, we may give them different names. Being like, if I have y equals 2x minus 3, well, I can just say, well, that is just function f of x, which is 2x minus 3. Well, let's say now I'm going to have another equation, y equals, let's say, x squared minus 3x plus 5. Well, this is a completely different equation. So if I want to talk about it as a function, I can't use f because I already used it here. I'd end up calling this one maybe g of x. So like I said, saying f of x, g of x, h of x, etc., those are just given at different function name types. We also have some like very specialty functions as well. Sometimes the names of variables are a reflection of the scenario being modeled. So if we were talking about the velocity of an object given at a given time, you might say that your function name you might call it v of t, because the function name is referring to it being velocity. And velocity is a function of time. So what we're saying is time changes, then the velocity changes. So velocity is dependent upon that time. We also sometimes have, like I said, very specialized names for functions. You may or may not see these ones, but just in case, some of these we will see actually. This one we will see, so this is a natural log function. So we know that if we see ln of x, we know that this means we're doing a natural log. Same as these ones. This is the sine of x. You could have an arc sine of x. So like I said, there are lots of other ones, but these are like just specialized names of functions that do something very particular. So Above is sort of like this idea we've always used for years of how we discuss what a function is like this machine. So the function pictured has been given a name, f. So we're saying our machine is now f. Here, x represents an arbitrary input. So my x's are going in here. They're going into my machine, and what's coming out are outputs. So just like a machine, usually you put in your material and one object comes out. You don't usually put in your material and two objects come out. Like I said, that's the idea of a function. One goes in, one comes out. One goes in, one goes out. So you're thinking of it being like a machine that works like that. And as I said before, when we talk about the function name, so f of x, like I said, that could be f of x. Sometimes we call it f at x, especially when x is given a particular value, or the value of f at x. So these are just different ways that we refer to f of x. Either way, it's always representing the output for whatever our input is. Also, like I was talking about before, that we can have two different x's come in and they would produce the same output. So that's another thing you can think about here as well, is that you could have two different items you put in here, but it can still produce the same kind of item. That's perfectly fine. Most functions are described by equations. Not always, but generally, and for us, for the most part, we're going to talk about them in terms of equations. Actually, we could draw on lines. That is just another variation of showing a function. For example, fx equals 5x plus 2 describes a function that takes an input x, multiplies it by 5, and then adds 2. So it's telling us exactly that what we do to that input. We calculate the output. We solve the equation. Oh, sorry, I got it there. To calculate the output, we would solve the equation y equals 5x plus 2. If we wanted to solve it for x equals 3, then what we do is that we just put, like we've always done in the past, you just put 3 in to replace that x. So we're going to get a little bit more into using this notation for evaluating. This was what we always called evaluating an expression or evaluating an equation. So this was evaluating for a particular variable or value. Like I said, this is something you've done in the past. We're just going to do it with function notation. So worst part about function notation is just the notation itself. The ideas are things that you've done a bazillion times. So another way to think about f of x is we are going to substitute 3 into a formula for f of x. So we had already said that f of x was going to be 5x plus 2. So if I want to find f of 3 instead, that means my x here got replaced with a 3, so the x was here also gets replaced by a 3. So if I asked you for f of 1, then that means I would just take that same equation up here, 5x plus 2, and I'd just replace x with a 1. So the idea is that this and this are like an empty space. Whatever I put in here, I have to put in here as well. So as another example, if we were asked to find f of negative 2, we know that what we're going to do is we're going to take this and replace it with that negative 2. We take that x, replace that negative 2. So what replaces in here replaces the x here. So these are just going to be some examples of using this function notation. So we want to find the indicated function values. So our function f of x is equal to 3x squared plus 2x. This right here says I'm just replacing all my x's with negative 2. So once I put this negative 2 in here, Well, that means every place I have an x is now going to be replaced with a -2. So we got 3. So a -2 squared, so it's -2 times -2. So remember, that's going to be a +4. This is 2 times -2. That will be -4. So we got 12 minus 4, which will be 8. So what we could say is this: f of -2 equals 8. So this is the same idea. Instead of using an x, I'm going to use t as my variable. So g of t is 6t plus 9. So if I do g of 4, that means that 4 is just replacing my t's. To our place I have a t, now gets replaced with that 4. So we're going to get 24 plus 9, which is going to be 33. Yes. Okay. And then our last one here. So this is a little different. So I'm not replacing with a number. Sometimes you can replace with a different variable, or sometimes you can replace your x or your variable with another expression. So we are going to use this empty space over here. So we know h of x is going to be 8x plus 1. So I'm just putting parentheses around that x because that's what's going to get replaced. So it's probably the best way to do it is just always write parentheses around that variable that you're changing. So if I ask you for h of m plus 2, well, like here, when I ask you for f of -2, I just replaced x with -2. Same thing here. I'm just going to replace x with whatever was in here. So that would be m plus 2. So whatever goes in here, goes in here. So h of m plus 2 is just going to be, if we distribute this, 8m plus 16 plus 1. And we've basically made ourselves a new function. So this is just a new function that we have with a different function name. So we started out with h is going to represent 8x plus 1. Well, h of m plus 2 represents 8m plus 17. I know it's a lot to take in, but like I said, it's just constructing what we're going to call is just new functions. So this is some things that we will use again in the future, which is why we're starting to practice with it now. All right, so if you take a minute and pause, you'll have question 11 on your worksheet. So 11 has 5 parts to it. But like I said, same thing, you have a function, and then here you're asked for f of -3. This one's going to be g, so g of 2. Same function, except now we're looking for g of 0. Then we have this h. In this case, we're replacing it with like another expression. So like I said, just take a moment to work on that, and then we'll come back and go through them. All right. So let's start on the first one here. So I'm actually going to use my space over here. Gives a little bit more room. There. So let's start with A. So according to A, we have a function called f of p. So p is my input, which equals 5p minus 2p squared. And we were asked to find f of -3. So that means every place I have p, we're going to place with -3. And I always say it might be easiest to write parentheses around all your variable, So you make sure that you keep signs correct and everything while you're doing this. So I'm going to put parentheses around that. So I replaced this p with -3. This p will be replaced with -3. And this p will replace with -3. Like I said, I use those parentheses so then I don't confuse myself and think this is 5 minus 3, because it's still going to be 5 times -3, because we had p or 5 times p. Like I said, the parentheses are just to help keep myself from not getting confused for whatever I'm doing. Once again, we got -3 squared, so -3 times -3. The negative cancels itself out, and we're just left with a 9. So now we have -15 minus 18. And that's going to be, we see 8, 9, 10, 12, 13, -33. Fix that so it looks a little nicer. Right. Now on to B. So for B, we had g of x is 3 times x minus 2 times x plus 2. All right. There's a reason I sort of picked some of these numbers here. If we look for g of 2, that means that this x here gets replaced by 2. And that this x here gets also replaced by 2. So we're going to get 3. And then we have 2 minus 2 here, so that's 0. We have 2 plus 2 here, so that's 4. So as you know, anything multiplied by 0 is just going to be 0. So this one just equals 0. All right, and then our last one, we're going to use all this space down here. So we have our function here. And this time we're looking for g of 0. So I'm going to replace x with 0. So we get 3, 0 minus 2, 0 plus 2. We'll keep continuing over here. And we have 3 times -2 times a +2. That's going to be a -12. So g of 0 equals 12. So just as a reminder here, this is my x, right? So we're saying that x is 0, and whatever pops out is my y. Or another way of saying it is that y is just g of x. So what we found here is we got a point where x is 0, y is -2. This was a y-intercept. All right, so our last two here, so these are a little more complicated ones. If you struggled with it, that's fine. It's okay to struggle, because when you struggle, it actually helps you learn, as long as you're not struggling too much. So here we have, both these are going to have the same function. H is going to be -2x minus 6. So this is similar to the one that we already did as an example. So we're going to have h of t minus 3. So it might help to just think of h here, once again, is that every place we have an x, there's parentheses, and those parentheses are going to be filled in. And what we know those parentheses are going to be filled in with is that already here we filled it in with t minus 3. So we're going to have -2. And then this x is going to be replaced with t minus 3. All right, so I haven't been doing this, but I'm going to point this out. I don't have to keep writing h of t minus 3 along the side. I can just keep writing the equals here. That is fine. So if I distribute this, I'm going to end up with a negative 2t. Negative 2 times negative 3 is positive 6. We already had that negative 6 out there. So we're just going to be left with negative 2t. So for this one here, if we replace h with t minus 3, then we're going to get this new equation of negative 2t. All right, and then for e, said we're using the same equation. And just remember, I'm just putting those parentheses around that x just so I keep myself from making some mistakes. So this time, I'm not replacing with a different variable. I'm still using the same variable. It's just had something added to it. So this is perfectly fine. So this is very similar to what we had before. Instead of having t minus 3, I have x minus 3. So I end up replacing this x with x minus 3. And this is going to be the most common way that we're going to use expressions inside of a function. So this is something we will see again. So in this case, h of x minus 3 is just going to be negative 2x.